In this video, we're going to talk about our next model of the atom made by JJ Thomson. So by the end of the video, you should be able to differentiate between Dalton's model and Thomson's model. To do that, let's review Dalton's model. In his model of the atom, all elements composed of tiny particles called atoms. All those atoms of an element are identical. For example, the picture, sodiums, they all look the same shape and the same size and the same properties. And then different elements are made of different atoms, so they'll have different sizes, shapes, and different properties. The atoms are solid and indivisible. Thomson's model proposed that atoms are actually going to have parts. So the question is, how did he determine that there's actually parts inside the atoms? He did some experiments. So he did an experiment called the cathode ray tube experiment, in which he had a tube, or a vacuum tube, means that there's air removed from the vacuum, there's no air, and it's connected to a power source. And when he connected it to the power source, it seemed like particles were actually moving between the electrodes. So you can see this side was connected to the negative power source, like a battery, and the other side was connected to a positive source. And there was a ray of light that traveled from the left to the right in this diagram and hit on this little plate on the other side that we can actually record how many hit on that side. So this came up with a couple of theories. When he placed the charge plates around the CRT, or cathode ray tube, he saw the beam pulled towards a positive plate. That means the particles themselves must be negative, because even back then, he knew that the particles opposites attract, right? So if they're going towards a positive plate away from a negative, they themselves are negative. And you can actually see a demonstration here where that's what the ray looked like. And what this person is doing is putting a negative plate towards the ray, and it's going away from it, because the same charges repel. Right? So proof that that ray is a negative ray. In that case, he determines the beam inside is made of particles that are negatively charged, and we call them electrons. These particles are 1,000 times smaller than the actual atom. The smallest atom we have is hydrogen, so it's 1,000 times smaller than the atom. And different metals give off different types of cathode rays, maybe more or less, depending on what kind of elements they were. So Thomson also found that the atom was, on a whole, electrically neutral. There is no charge in the regular atom, and then somehow with electricity we can find the electrons. So that means there must be positive charge somewhere within the atom to balance out that negative electron we found. And so the way he described this was using something called the plum pudding model, and yes, that is the real name, where the atom is actually positively charged throughout, and it has these little negative electrons stuck inside it. Kind of like if you had a muffin, the whole entire muffin would be positive, and there might be like little negative chocolate chips throughout. Right? He actually thought of it as plum pudding because back then, in 1897, I guess that's what people were eating, not muffins. And so he said the pudding part's positive, and the negatives were the little plums that you could see in there. At this point, I want you to be able to compare and contrast Dalton and Thomson's model of the atom.